Have you ever thought about the space between things? Not the objects themselves, but the gaps, the air between your hands, the space between atoms, the vast darkness between stars. We usually call that nothing. Empty space, the background, the part that doesn't matter. But here's the strange truth. Empty space isn't empty at all. In fact, it's one of the busiest places in the universe. Right now, as you sit there watching this, every bit of space around you is buzzing with activity you can't see, feel, or sense in any way. Not because it isn't there, but because your senses were never built to notice it. What we think of as nothing is actually doing a quiet, constant dance. And that dance shapes everything. To understand why this matters, we need to start by breaking one of our most basic assumptions, the idea of nothing. When we imagine empty space, we picture a void, a blank gap where things stop existing. This idea makes sense based on everyday experience. If you remove the air from a container, it feels empty. If you move far away from objects, there's less stuff around you. But physics tells a very different story. Even in the emptiest vacuum humans can create, where almost all air and particles have been removed, space is still active. It still has structure. It still has energy. Things are still happening. Space is not a silent backdrop. It's more like an ocean. On the surface, an ocean can look calm and flat. But underneath there are currents, pressure, movement, and life. The deeper you go, the more activity you find. Empty space is like that, calm to us, turbulent underneath. The reason this surprises us is simple. Our senses evolved to notice solid objects, things we can touch, see, and hear. We're very good at tracking rocks, animals, and tools. We're terrible at noticing the fabric that holds it all together. But modern physics forces us to look deeper. According to our best theories, the most basic ingredients of reality are not tiny solid particles floating in nothing. Instead, reality is made of fields. A field is something that exists everywhere, even when nothing obvious is happening. Think of temperature. Even if no one is measuring it, temperature exists throughout a room. Or think of the ocean again. Water exists everywhere in the sea, even where there are no waves. Quantum fields work the same way. There is an electron field that fills the entire universe, a photon field for light, a Higgs field that gives particles mass, many others all overlapping in the same space. These fields are always there, at every point in space, even in places where there are no particles at all. So what is a particle then? A particle is not a tiny dot flying through the emptiness. A particle is a ripple, a small disturbance in one of these fields. When the electron field vibrates in a certain way, we see an electron. When the photon field vibrates, we see light. When the vibration stops, the particle disappears, but the field remains. This means something important. Everything in the universe comes from the same invisible backdrop. The chair you're sitting on, the phone in your hand, your body, the stars. All of it is made from ripples in fields that fill empty space. Space isn't what things sit in. Space is what things are made from. Now here's where the dance really begins. Even when no particles are present, these fields don't sit still. They can't. At the quantum level, there's a rule that says you can't completely freeze a system. You can't know both the exact energy and the exact state of a field at the same time. There's always uncertainty. That uncertainty causes constant motion. As a result, empty space is always producing tiny, short-lived disturbances called quantum fluctuations. These fluctuations briefly form pairs of particles and antiparticles, then vanish almost immediately. These are often called virtual particles. They don't stick around long enough to be seen directly. They pop into existence and disappear in fractions of a second. But even though they're brief, they're real enough to have effects. This isn't speculation. We can measure it. One famous example is the Casimir effect. When two metal plates are placed extremely close together in a vacuum, they're pushed toward each other. Not pulled by magnets, not pushed by air, pushed by empty space itself. The reason is that quantum fluctuations behave differently between the plates than outside them. The imbalance creates a force. Nothing is pushing something. Empty space is. These fluctuations also play a role in how atoms behave. They slightly shift the energy levels of electrons. They affect how particles interact. They help explain why forces have the strengths they do. In other words, matter relies on the activity of empty empty space to exist in the way it does. Then there's something even stranger. Even if you cool space down as much as physically possible, removing almost all energy, something still remains. This leftover energy is called 0-point energy. 0-point energy means the lowest possible energy a system can have. And even at that lowest point, the fields of space are still moving, still fluctuating, still alive with activity. They never fully rest. This leftover energy affects the size of atoms. It influences chemical bonds. It shapes how matter holds together. Once again, nothing turns out to be something. And this challenges our intuition in a big way. We like to think that only things have weight and influence. But physics tells us that empty space has influence too. It pushes, it pulls, it shapes outcomes. On the larger scales, this becomes even more important. When we look out into the universe, we see that it's expanding. Galaxies are moving away from each other. And not just moving, accelerating. Something is pushing the universe apart. This mysterious force is called dark energy. We don't fully understand what it is, but one idea is that it's connected to vacuum energy, the energy of empty space itself. As space expands, more space appears. And if space carries energy, that energy adds up. On cosmic scales, that could explain why expansion speeds up instead of slowing down. If that's true, then empty space isn't just passive. It's driving the future of the universe. Space also bends and curves. According to general relativity, mass and energy warp space itself. This warping tells matter how to move and tells light how to travel. Planets orbit stars, not because they're pulled by an invisible rope, but because space around the star is curved. Light bends near massive objects because space bends. Even the emptiest regions between galaxies aren't truly empty. They're filled with fields that guide how matter forms, how structures grow, and how the universe evolves over billions of years. The universe doesn't float in space. Space is the active stage on which the universe unfolds. So why does any of this matter to us? Because everything you experience rests on this invisible foundation. Your body is held together by forces that arise from quantum fields. Your thoughts depend on chemical reactions shaped by fluctuations in empty space. The atoms in your brain rely on rules that exist even where nothing seems to be. You are not separate from empty space. You are built from it. Understanding this changes how you see existence. It means creation doesn't come from nothing. It comes from structure already present at the deepest level. It means the universe isn't a dead stage with objects placed on top. It's active, restless, and full of potential. The space between things is not absence, it's possibility. And the more we learn about it, the more it seems that what we call nothing might be doing most of the work. So, here's the question worth sitting with. If empty space is always moving, always shaping reality, always creating and influencing everything we see, was the universe ever truly empty at all? Comment your thoughts below and don't forget to like and subscribe while you're there.